Alright, we are back to the Philco Predicta Princess chassis. Last time we just kind of looked at them, we did a quick power up to see if it worked. We did get a raster out of this, we know we have high voltage and that everything appears to be working relatively okay. And we discovered that the fusible resistor right here is hanging on by hopes and dreams. Surprisingly functioned long enough to get the set working, but not much more anymore. What I have been working on in the meantime, well, really I've been trying to diagnose the problems with the Sylvania set. I'm putting that to the side for right now because it's not an immediate need. These I have more of a time frame, not as much time. So what I've been doing is planning my attack on getting into the main board here because it needs to come out so that I can get to the side, the underside of everything, so I can dismount all the parts. My couplets actually showed up, which is nice for both Predictas. But I need to order up new sockets, and there's some of these caps in here that I need to tally up and place orders for because I kind of burned through a lot of my more common values doing the Sylvania. And I want to take stock of the electrolytics we're going to need. Although there's only 3 of them in here. I don't know how many sections this is. I don't remember if I said that in the intro video. I might have. That's a 4th section. This is a single. This is probably a double section. Either way, I need to tally all those, see the values are. What I'm working on immediately, though, is getting this out. My original hope was that I could simply undo all of the solder posts. And here, let me get this in frame. So the Predicta boards in all these models are mounted in place not by screws or anything, you know, that would make sense. Instead, we have the same tabs that are actually used as tie points for connections on the board. There are a few of these attached to the ground, well, it's not really a ground plane, but the ground connections at various points on the chassis. There's a punch through with a little U-shaped collar in there, and these test points are simply bent over into that crevice and soldered in place to lock the board down to the chassis. I've already gone in and I've unsoldered them, peeled them back, but unfortunately the chassis is held in by more than just those. For one thing, I think this is the vertical output transformer. The edge of the windings here actually captures this edge. A lot of wiring tucked down here at this end, holding it in place. This switch is bolted and I unscrewed it there, so that helps. I unscrewed the socket, so that kind of helps. But there are a pair of potentiometers on the back here that are attached to the board, and they come in direct contact with the width control pot on the back, and that is not screwed in place. That is a twist lock, and I am not risking snapping those off. So now my only real option is I wanted to try and just kind of lever it out and have all the wires be attached. That ain't happening. I'm going to have to disconnect all of the main connections around the board and then pick it up and back and out. So, to that effect, I have made a map similar to how I did the Holiday. The Holiday had a hell of a lot less connections. This one, I simply started at some random point on the board, basically the top left, and I took note of every wire connection that goes around, as well as drawing the rough locations. There's a bunch here in the middle. There are some posts on here with wires between them that only go between posts on the actual board. So they're not all necessary, but I numbered them 1, and thus far I'm up to 30, 34, like 35 different connections. These guys up here, I believe, are part of the audio circuit. Volume control, yeah, that goes to the control head that's hanging off. So I've numbered all of these, and the plan is I undo one at a time, and then I'm going to label each wire with the corresponding pin number until they're all done, and that'll get them out of the way. I mean, I suppose I could unwrap them and just see where they lay, but I don't want to take the risk of forgetting, because I will forget. What I'm trying to figure out now is how I want to label them. My initial thought was to use a piece of tape and wrap around it, but a lot of these wires, especially the ones in here, are not very long. And they might not be the easiest to do that on, so I'm looking around to see if I have anything that would easily do that. I want to say I had Post-it note strips, and I think would probably work pretty well. Let me see here. Oh, you know what? These are still adhesive. Okay, I'm going to try and use these. suppose I could just cut up a Post-it note, but this is an old freebie I got from college. These little guys are here. I can wrap those around a wire and put a note on them, and that should work pretty well, and they stick to themselves. So I'm going to do that, and I'll get back with you when I have any kind of progress made. Well, my order from Mauser arrived, and with the board out, it's time to get cracking on replacing everything. This mess you see in front of you here is part of my Mauser order. I had probably $250 worth of merchandise in there. Not all of it goes on that board, but at least one of every single one of these packages does. There's a handful of capacitors on there, maybe a dozen or so. The problem is the resistors. They're all half watt or larger, and my collection of half-watt resistors is sorely lacking, and there's a lot of very high-value components that are not super common, like 1.8 mega ohms or 2.3 or what have you, or 12 mega ohms. None of the part sets that I have go above 10. I can't even measure above 10 with most of my meters. So I went through Mauser, and I tried to get carbon film resistors if I could. There's practically no variety on Mauser for carbon compositions resistors anymore. They're just ceasing to make them. So there's no way to put these things back 100% factory because A, they don't make paper caps anymore, and B, the carbon comp resistors in there are drying up. They are being phased out. I think Allen Bradley was like one of the few companies that was still making them. Or maybe that was Vishay or Sprague or someone. Either way, there are at least 47 values of resistor on this board, and there's maybe 2 resistors out of that bunch that share the same value. Everything else is completely different from each other. And there's a number of high wattage ones on here. If we look a little bit closer to the board here, most of them are going to be your typical half-watters, these little guys in here, but we have a number of 1 or 2 watts, like that guy there, that guy there, that guy there. There's also a cement resistor on here that's a little over 4 kilo ohms. That one I didn't buy a replacement of because the cement resistors are wire wound. They don't tend to go bad, or they don't tend to drift, I've usually seen. Not like a can dome or something. But the carbon comp resistors, yeah, they can absolutely go bad and drift. And considering how hot this thing gets, not taking any chances. Everything is getting replaced except for the ceramic discs. They've got pretty good lifespans. All the couplets. My sockets have not arrived yet. They're supposed to be here tomorrow, so I'll be able to get those dealt with, and I have a solution for dealing with this tube socket here that has the special shield on it that pops up to cover the tube there. These shields are actually not mounted to the sockets. They are simply mounted through holes drilled in the board, and then solder lugs pop through there and attach to the ground plane. These are just normal sockets. I should be able to unsolder and pop the shields off, remove the sockets, put in the new ones, which are, especially for that one, substantially smaller. Fit right in there, no problem. And then I can put the shields back in place. This one, the shield is actually mounted to the socket and is attached to the center stud, which has a tail that comes out the back and attaches to the ground plane. I ordered from Antique Electronics Supply a 9-pin tube base that comes with an integral tube shield mount, one of the push and twist lock styles that you commonly see on TVs. And it also has its PC mount on the socket, but it has a pair of wings on it for mounting to a chassis. My plan, such as it is to position it so that one of those holes is above the ground plane, and there is a point in here that it is, and then I'll drill a new hole from the PCB side through the ground plane and add a wire from that up to the socket base and create a solid ground for that shield. It won't look exactly like the original, but the socket will be better shape, or definitely an upgrade, and it'll still be fully shielded. Why this board has shielding and the 21-inch that I have does not, I'm not entirely sure. But I want to make sure I shield the tubes that they felt necessary to shield anyway, and not just chuck the shields and say, whatever. So, that's the plan. I've already done a few of the film caps that I had on hand. I had to wait for a few of them. Just like on my 21-inch set, there is one capacitor, this guy right down here, that I believe is part of the audio circuit, that's rated at least 1,000 volts, a 0.0015. I've got a new replacement for that one. That's in the vertical section there. This is the audio output tube here. Well, either way, that was the only really high value on there. There were some other more standard values, 0.022, 0.033, 0.068, that sort of thing. So I'm actually going through the capacitor selection that I have, and I am updating my selection with modern values. When I started, I bought a kit from, God, I can't remember his name now. The gentleman in Canada that sells capacitor and resistor kits. And when I started, I bought one of his capacitor kits that used pre-40s values, so 0.03, 0.02, that sort of thing. Anymore, I don't see much of a point to stock both. I would much rather have the modern values because there's plenty of overlap between the new values and the old. 0.047 will replace a 0.05 and so on. And plus, more and more with TVs now, I'm needing some of those larger values, the 0.22s, the 0.15s, the 0.068s, or the 0.082s occasionally, and I just don't have them. So I am revamping my storage, and I am replacing all the old values with new ones, which should actually open up some space because some of the overlap in the parts values covers more than one part sometimes, or more than one value. Barring that, I'm going to move all this crap out of the way, and I'm going to start replacing parts. Oh, by the way, if you are buying stuff through Mazda or DigiKey, I initially went into it looking to buy one or two resistors of each value that I needed, but the price specs on resistors, even the half-watters, are really good. I ended up buying, for most of the standard values, 3.3, 100 kilo ohm, that sort of thing, I bought at least 100 of all of them. I'm pretty sure my cart would have been much cheaper than 250 bucks if I had just bought 5 of everything instead of 100 of everything, or mostly everything, but I use a lot of these half-watters in sets and radios now, and there's just no reason to not have them on hand, so I took the opportunity. You have something to say? Yeah? I should get to work. Okay. Okay, we've moved forward in time. Quite a bit, actually. It took me a while to get everything carefully sorted through. When I went through replacing all the resistors, I tested the originals in circuit before I pulled them out, and I tested every last new one to verify value before they went onto the board, just to make sure I don't really screw something up. But yeah, that all went relatively smoothly. I got all the new tube sockets installed. These shields here were very easy to remove. There are simply 2 pins that stick down. They're tabs, actually, and they're folded over. So I removed the solder from the relevant traces, unbent them, and then just extracted them. And put them back once the new sockets were in there. This socket, however, which was originally this guy here with the extendable dude, I couldn't find a good replacement for this. There's really nothing like this out there. The ones that I did get, the PCB mounts, don't have the shield already attached to any other point on the socket for easy grounding, which I found kind of obnoxious, considering that's kind of the whole point. I mean, it's a PCB mount, but then you also have flange holes? I mean, it's mostly for amplifier stuff. So I kind of had to wing it. One of the pins on this socket is actually connected to ground and to the center post, at least on the original socket, and since this one has a mechanical connection from the shield to the center post, I figured there was no harm in simply adding a wire from the grounded pin to one of the flange holes here. And I say it's mechanical because I cannot get it to accept solder. It just won't. I checked the electrical conductivity between the original and this one, and they're pretty much the same. They're both relying on a mechanical joint. With solder on there, it's not going to oxidize, at least on the wire. So that portion is shielded, but I ran into a slight snag because the original shield that comes with this, I did not realize, was really meant for tubes like a 12AU7. Relatively short stuff like, you know, like this. This is actually it's a 6B-K7A. That'll work fine with there. The little spring inside there won't have any issues. Shouldn't have any issues. Unfortunately, the tube that actually goes in there is not the size of the 12AU7. It would be... is it the 6DR7? 6AW8. I can't quite remember which one of these. I want to say it was the 6DR7 here. Or the 6CG7. Well, it was one of these guys. Either way, these are substantially taller, or they're just tall enough where trying to put one of those shields on there doesn't quite work. The locking tabs don't engage, the spring compresses, and then, of course, it actually tops out completely on there, and there is no way to get it on. At first, I tried using one of the cheap clamshell style and just slipping it over the top, because once you insert it in there, it does make contact with the shield base, but that looked cheesy. And I bought new sockets, I bought new shields, I really wanted to use these. So I came up with a workaround. I actually enlarged the hole in this one using a step drill. I trimmed down the spring by about half, and then I slightly opened up the little slots down there on these. Not by much, just enough. So now when I pop this back in there, and I use my enlarged tube guy, it should just go on there. I did this before, and now it's not going to, there. And that's that. It's not my greatest work, I would say, but it does fully shield the tube, and it's got good conductivity with the shield that it's designed for. So I'm going to use this. I might look into other options for my other set. I wish there were more shielded PCB mount tube sockets, but really this is the only thing that I could find from a major supplier. From tubesandmore.com, the amplifier guys. If anybody knows of a different variety, throw me a link in the comments or something. I'd love to know. That was the only major hitch. Pretty much everything else went pretty well. Couplets installed easily. Don't need to replace these two because they are a one-piece design. They're not the crappy double physical contact things. These disintegrated. When I went to remove them, they just crumbled. So replacing all of them with ceramic was a good choice. The only resistor in here I did not replace because I could not get a replacement was this 7-watt 4.1 kilo ohm cement resistor here. This one does still measure within tolerance. It's a little lower than I would like, but it is still within spec. The only easy solution I would see to replacing this would probably be to use a pair of 8.2 kilo ohm 10-watt resistors in parallel with each other to get back down to 4.1. I don't really want to bank on one of those. Well, if one of those resistors dies, then it just goes high value, I guess. That's not the worst thing, but I thought it would look a little cheesy. In the future, I could do that. It wouldn't be super hard to do, but this is still within spec, and I replaced everything else around it, so it should be all right. Capacitor-wise, the only one that stumped me initially was this one up here. This is the tank circuit. I'm gonna make sure you guys are in frame here. This inductor here and this capacitor right here is a 0.0039 microfarad. This is the tank circuit for the horizontal oscillator for the free-running frequency. The original is an axial lead. I could not get axial lead. I couldn't even get much of a variety of anything for 0.0039. I probably could have just gone with a 0.0033. Those are a lot more available. I still have some. But I really wanted to get as close to the original value as possible, just because I don't want to have to do a whole bunch of readjusting on the horizontal oscillator frequency. So the only one that I could get within a 630 volt DC range were these little blue guys. Let me see if I can grab one for you. So these are quite tiny, and they have very, very stumpy leads. Maybe half a centimeter, barely. But they are the rating that I wanted. They are film cap. Problem was the lead spacing. Since the original one was axial, what they actually did was they installed it vertically. So it came up, and top lead bent over, and then went back in, which meant that the hole spacing was really tight. Tighter than this distance, actually. My solution was to just bore a brand new hole in the existing trace on this end of things. I just went straight through the PCB, very carefully not to rip it off the backside, so that this would drop right in without trouble, and then I bent the leads and soldered it. So that worked out well. I do believe I have found a slight typo, though, on the SAMs. So I am using the SAMs photo fact. I don't have the original Philco data for this. This resistor right here, which is, I believe, SAMs number R76. Let me make sure I'm not talking out of my butt on that one. Printed everything off here. Yeah, that's R76 on the SAMs. It's supposed to be 390 ohms. They listed as a 1 watt component. On the board here, this is Philco part number R54. I don't know what the Philco drawing says it should be. The SAMs claims 1 watt. This is not a 1 watt resistor. This is a 2 watt at least. And I went back through to the SAMs to double check the voltages and where this is being used, because I figured, well, it's kind of near the horizontal circuit. It's pretty big. It's got to be supplying something with plate voltage. It is actually. This comes directly off the B plus terminal. This is getting 275 volts directly off of the high voltage rectifiers, and it is knocking 20 volts off of it to provide a 255 volt bus for a few of the other resistors, including the cement one right here. So there's a 20 volt drop across it. I did the math on it, and that actually comes out to exactly, or damn near exactly, 1 watt of heat dissipated. So you're like 1.0012 or something. It was pretty close. And I had 1 watts originally spec'd for this, and I already bought them. I decided that since very obviously they went with a 2 watt, putting exactly the same value was not a good idea, so I doubled it. Got some 2 watters off of Amazon, so that pretty well wraps that up. I've cleaned up most of the ground posts. I'll probably need to do a little bit of burnishing on all of the connections here, because the next step is going to be to pop it back in the chassis and verify that everything here works before I go and tackle the power supply. Alright, it's back in. I've got all of the ground solder lugs flipped back over and locked in place. Thanks to my map and all the labeled wired connections, getting everything tucked back in was very easy. Transformer bolted back down. Before I actually go and power back up, so there's a little bit of housekeeping I want to do. I'm not going to go through the whole power supply, but there are a few easy to do things that I want to make sure I cover before I go crazy with it. So looking over at the high voltage cage area, I've actually got the cage off. So I took this guy out because this is actually directly in my way, because back on the right side of it, tucked against the power transformer, is this capacitor right here, which is 0.022 microfarads. It's directly across the power line, so I've got a brand new X2 type that I'm going to swap that out with. And then, of course, there's also this single section electrolytic coming off of one of the rectifier diodes there. I'm going to go ahead and swap that out. This is 200 microfarads at 150 working volts. Going to replace it with a 220 and 160. Get that out of there. I have also swapped in my one good remaining sand resistor since the original one had disintegrated. I'm going to look into making a slightly more modern replacement with like a fuse in it to replace the old fusible run. And then there is one more paper cap. It's actually stuck right in here, and I just flipped it over and realized it is split right up the middle between the leads, so that needs to go away now. And yeah, whoops, sorry. Being inside the high voltage cage allows me access to the flyback, obviously. This, I need to put some dope on. There's a lot of cracking in here. I want to cover all that back up. The grid cap for this 6DQ6, I think it is. It's pretty nasty, pretty corroded. I want to clean that up. And there is a single carbon resistor on the plug here for, I believe that's the yoke connection. And I'd like to take care of that too. And maybe blow some of the dust out of this area. So I'm going to get started on that, and I'll get back to you when it's wrapped up, and then we'll plug it in. Oh, by the way, I should mention, getting the high voltage cage off on this was a little obnoxious. The way it's mounted, there's a single screw here on the foot that's tucked just in front of this transformer. There's another one in here on the side that you can only get in from the back here. It's at an odd angle, so having a small ratchet at a right angle is very handy. And then the last one, which is rather tricky to get, you have to flip the lid up here, and it's this little guy in the corner. That one can only be accessed from a right angle, or I had a really long extension that allowed me to come up and go in like this, because it's at a weird angle. And of course you have to unbolt the clamp holding this electrolyte to the side of it, get that out of there, and then the grid cap on this guy just slides right out the hole. No big deal. And yeah, that should about do it. I will catch you in a few minutes. Okay, so my initial power-up did not go as planned. I found I could not get filament glow out of the damper tube, the horizontal oscillator, and this little guy right here, the 680W8A, which I don't actually know what that one does in circuit right now. Couldn't get filament glow out of them. And if I nudged the board slightly, I could get crackling out of the speaker. So I wasn't quite sure what was up with that. I looked at the board again and I realized two of the ground posts, I'd missed them. One down here in this corner and one tucked up here with a damper tube. And I had a suspicion that since this is a series strung filament circuit, the tubes are actually grouped to some degree, so they're not all in a Christmas tree fashion. Or, sorry, they're not really series strung so much. It's got a power transformer with a filament winding. Some of these tubes have shared common connections to the filament winding, and then some of them have clusters of ground connections for the other half. Well, it turns out that these ground posts here are actually the other half of that. I figured there was a common ground plane. No, there are different ground traces that are individual to localized areas here. So some of these tubes over here happen to share a ground connection, one of those being here. This tube right here appears to ground to that pin. Not having connected those, every time I pushed down in the tubes, I was briefly remaking contact with those grounds. So I've resoldered those. I've disconnected the sand resistor, which is just for B+, and I'm going to dim the lights, and we're going to see if I now have filament glow in all the tubes, which I should. And yes. Yep, and horizontal oscillator tube maybe. Yep, I think I see the dual filaments for that one coming up. Yes, we do. Alright, that was the problem. Two grounds not connected. So, everything is lighting up. Excellent. That means I can reconnect it to the set again, and we can see if it works. Now, I don't have the power supply 100% dealt with. The main electrolytics are still in place for the large part, but we have a raster. It is rectangular. It is not centered, but whoop-de-doo. Let me check and see if the height control works. Yes, the height control does in fact work. Great. Horizontal frequency adjust. It does not like that. But yeah, we have deflection. Oh, we do have a width control right here. Yep. Width control is functional. And there's a vertical linearity, but I'm not going to mess with that because doing it right now is kind of pointless. But yes, how far up are we cranked on the brightness? Ooh, yeah, we're cranked pretty far up. Where's the max out? That's max. So, yeah, not superb. Okay. I tell you what, we can try sticking a signal source of some variety on it. Considering the amount of interference being output by the transformer without this cage on there, I don't really know how well it would work, but let me see what I got here. I can't actually tell what I'm looking at the moment. Crosshatch. Oh, I think something was happening there. Hang on. If I sweep. Yeah. Right about there, we are picking up a signal. Let's try the horizontal. Aha! And the vertical. Somewhere around there. Okay. Contrast should be this one, I think. Something along those lines. But yes. It is actually picking up. I haven't done anything to the tuner yet, but yeah, it is picking up the signal generator. So, that's good. Actually tuning in a little more than that. But yes. Okay, so the IF and RF stages do work to some degree. Deflection circuits are working. I think I will call that good for right now. Perfect. All right then. So that's a pretty good state of affairs thus far. The next step is going to be dealing with the two remaining aluminum multi-section cans, and I need to go through the IF strip and the tuner. And I figure that'll probably be the last part. There is actually, I had to double check on my couplet set, there's a couplet that lives inside the IF strip. Let's see if I can't find it here. I moved everything around, made a mess. Well, either way, it's a two-terminal device, and I wasn't sure what it was at first until I checked the parts list, and I realized it's basically just a capacitor and a resistor in one little package, but it lives directly on the IF strip there. And I would have missed that because my kit for my Holiday, I think, also came with a two-terminal device, and I wasn't sure where it lived. Well, I haven't touched the IF strip on it yet, so I should probably double-check that. And I want to go through the resistors on there and see how they are. The tuner does seem to have a few, at least two high-wattage resistors, 1 or 2 watts, I think part of the plate supply. So I want to check those, and there is a paper cap on the actual tuner. Everything else is mica or ceramic disc. So that's what we're going to do. But I will save that for the next episode. And as always, thank you for watching, and I hope you have a good weekend.